I'm here in Williamsburg, Virginia, where Alquist 3D is building a house for a single mother with a son, a family in need for Habitat for Humanity, with their COBOD BOD 2.5 printer. They're running the printer right now behind me. You can see they're about 4 or 5 layers in. They're going around some of the initial layers with a trowel to flatten it out and give it a nicer finish so that it has a nice smooth exterior. Some of the layers without this may be slightly sloppy looking. The extruder has flaps coming out the side, so as they get higher, the flaps will prevent the extruded walls from going over each other and keep it uniform so that it looks nice. My name is Jared Gross, and I've been traveling the world, Asia, Europe, soon the Middle East, to every 3D printed construction project I can find, because I think this technology really has the potential to change the construction industry and improve lives for people around the world. This project is really an experiment. They're testing out what they can do with this printer, and Habitat for Humanity is assessing its viability for addressing the housing crisis at a larger scale. As you can see, I'm using a lavalier today. I've upgraded some of my equipment to improve the sound quality. I know that was very important to a lot of you, and I was able to do this because I got so many of you to like and subscribe to my channel, and now I'm able to reinvest with some of the ad money generating from the YouTube channel. I also just launched the virtual village of 3D printed houses. Every building I go to, I take a virtual 360 tour that gets uploaded and hosted on Matterport. You can walk around these digital files from your screen by just clicking and dragging around and clicking on whatever part of the floor you'd like to walk to. You can examine then the 3D printed house in a 360 view, seeing everything around you from the ceiling, the floor. A lot of these projects were still under construction, and so you can see the holes for the outlets and the raw printed walls before any work was done to them, pre-finished quality. It's a really interesting way to see these houses, and for a few more days you can use the code FOUNDINGMEMBER for 40% off. Check out the link in the description below.
So my name is Ahmed Hussein. I recently graduated from NC State within their technology, design, engineering, education department. I've been 3D printing in FDM printing, which is typical desktop printing, since I was a sophomore in high school. This is Alquist's second home. We just got off a project in Richmond, Virginia. That home was kind of our trial piece. Was something as big as this and inconsistent in nature. There's a lot of learning curves with 3D printing. It's like riding a bike, you know. So when you first get a bike, it's hard, you fall a couple times, you make some errors. Some of those have resulted in material inconsistency, some small flaws here and there, all of which we're planning on fixing and altering before we start printing the house behind me. Another thing we had to troubleshoot throughout the Richmond house is finding kind of your magic numbers as far as speed, as far as extrusion rates, and just managing water levels and cooling. There's a lot of things that have to come into play, and everything has to align nicely. Obviously, when you start at 5 a.m. and end at 1 o'clock in the middle of summer, your temperatures are drastically different, and so altering those at certain times of the day is essential.
So now they're on layer 5, they're putting these ladders in between. This is a horizontal reinforcement, metal reinforcement. You can see these are just small pieces of metal, and it creates a little bit of strength in tension within the concrete layers. Check out this hose system they have above me here. The hose runs from up there all the way to the extruder. It has the concrete running through it. This is a critical part of the process, and you cannot have a clog, otherwise you could ruin the whole hose. It runs from up there into the pulley, and then there's a bobcat with a rope tied to the hose to make sure it doesn't swing into anyone. It's very thick, and with so much concrete running through, it's extremely heavy. So it's very important somebody is aware of it at all times, so no one gets hurt. Notice how the machine is able to stop and start itself. It can pause the flow of the material so that adjustments can be made on the fly, and then it can resume right from where it left off. Right before it stopped, if you looked closely, you'll notice it did a twirl. This leaves you with a more uniform residual amount of concrete on the layer, rather than just pulling up without the twirl, which would leave you a floppy mess. Here's those ladders we were talking about earlier, giving you horizontal tension strength. The material needs to come down all the way through that very long hose from the silo. And so adjustments that they make over there aren't reflected at the extruder until it gets through the entire hose. Over here we've got arguably the most important part of the job, where the silo pumps the dry material with the water through the hose to the extruder pump. One little mistake here could ruin the print, make you have to start over, it could ruin a hose. Everything you get at the end comes from this part right here, so without this, you're screwed. They set up some shade so that the water doesn't get too hot. They've also got a bunch of ice they're using to cool the water getting mixed in with the powder concrete mix. This makes it easier for them to print on this extremely hot day nearing 100 degrees Fahrenheit. And over here we've got the command center, where the operator mans the printer and can start, stop, resume anything that needs to happen during the print process. Here we just got to check out the start-stop function of the printer. Unlike many other concrete printers, they're able to pause the concrete flow to make adjustments on the fly and then resume the print from the part they left off. If you look really closely, you can see the one flap that they have on the extruder currently.
It's coming out?
It's coming out.
But slowly. Stiff.
Yeah,
Slowly.
it's coming.
It looks dry.
Increase the water, go for it.
Now they're coming around spraying water on the wet concrete to help it cure healthier. By keeping it wet, you can prevent cracking. Before they started today with the wet concrete, they put down a bonding agent so that you don't have a cold joint concrete on concrete. Another interesting quality to notice is how they've used a trowel to smooth out the concrete on the left side. The right side they haven't done yet, they still may, but you have these somewhat uneven layers here, whereas the other side looks perfectly smooth. It's a much nicer finish and it'll make it easier to plaster over in the end of the job.
Sledgehammers are typically used to break up any clog that would have happened. If you look behind you, we have material.
You put a ball in?
Yeah, ball in. The worry of clog is kind of mitigated at this point. Currently we have the hose stick from our operator to be able to better monitor the problem was catch the ball.
So they were just faced with a clog in their hose, which meant they had to pause the whole system, smash the hose with sledgehammers to get rid of any clogs, and flush it out to make sure it all runs through clean again. In the end, you see the printer kind of overflowing with water until they finally get the clog out of the extruder head as well. Now they're power washing the whole system and they'll start the print again. Tim is the guy power washing the extruder, and he's a critical part of the project. He was with the Alquist team in Richmond and came all the way here to Williamsburg to help with this print here. Once they get the clogs cleared completely and it's all cleaned out, they'll set the material up, get it flowing again, probably perform another slump test before resuming to however many more layers they're going to be able to print today. People think of 3D printed construction as automated, but you can tell there's a lot of people involved. You have watering the concrete, making sure it cures properly, cleaning the extruder head, getting ice to keep the water cold. All of these tasks require human labor, and so it still takes a lot of people to get the house built.
Everything in here and then the print head and project back to them what changes need to be made. Or sometimes I'll let them know like where we're at so that they can make the decision to what change, because with their speeds and everything.
So right now you guys cleaned up the hose, flushed everything out, made it clean again. and you're starting the material to run through, how will you know when it's ready to start the next layer?
So that's when I'll check for the consistency. He'll extrude it. So right now what they're doing is they're priming the hose. Priming the hose is basically like a really wet concrete mix, and then the material will start coming through. So I'll check the material as we have now. Some of it's coming. So once we get that right consistency of the material, I say let's go.
What is the right material consistency? How can you tell?
It's kind of like a sundaes you get from McDonald's.
Okay.
I don't know what they're called. I don't get them. They said it. Yeah, something like that.
Okay.
It's like ice cream, like a real thick ice cream.
Sure. And then it gets hard after like a minute or so, one layer?
Well, it starts to harden immediately, but each layer takes about 20 minutes to dry.
Now it's much thicker, getting closer. Maybe it's like a milkshake.
Yeah, and that's still some of the slurry coming through. So I need to check the material coming in.
Obviously, the material consistency is an extremely important part of the job. If you don't get the material right when you lay it down, it'll be wrong for the duration of its existence.
My name's Aaron, and I am the mixing pumping tech. I'm in charge of this whole station here. This is the Mtec Duomix 2000 mixing pump. We've been getting our material from Quickcrete, and they supply our silos as well. We've been through a few different silos, most of them much smaller than this. We're really excited about this one because this will allow us to print continuously throughout the day without having to refill bags of mixture. Each bag that we have is a super sack, weighs about 3,000 pounds, and we typically go through about 4 bags during a print day. The material is loaded at the top by a forklift. We then have a dispensing mechanism to bring it down through this sleeve. It's all still dry until it gets all the way to this side. The water then mixes with it and goes through the pump all the way up to the print head. It's super fun. Alquist 3D rocks. On the Mtec, there's a lot of pieces that can wear down over time. This is one of those things. This is made out of plastic, whereas pretty much most of everything else is metal. And so we're pretty new at this, so we didn't realize that this could wear down within just like 3 weeks of printing. This whole unit is about $1,000. This little piece here is just about $90. But even just to get that shipped to us would take some time, and we were in a rush, so we had Eamon 3D print this piece. We've been using this yellow rotor and stator combination. This is the stator, this is the rotor. It's a spiral pump. This is kind of our third chilling system that we set up. The first run that we did, we tried just having about, I think it was 300 feet of regular garden hose coiled inside of an IBC tank. We actually have it still over there, but kind of similar to this tank here. Just a big plastic water tank. That wasn't really sufficient, so we added 100 feet of copper coil into that, and that seemed to help. Seemed to be more efficient. The next upgrade that we've been looking into is to buy an industrial chiller that would attach to this system and basically replace our ice wall.
Overall, it was a pretty successful day. We tested out a new system with our water cooling, which is a compressed system which kept our water really cool, allowing us to print farther in the day. Secondly, we had a new binding system in our walls that worked adversely, so those are really impressive. We used our 2-inch flaps that 3D printed on a traditional 3D printer, and those worked very successfully and kept those nice, smooth, consistent lines. Not quite the day we were looking for. We were looking for closer to the 15 layer mark, but that's kind of just concrete 3D printing. You know, some days you're able to flow consecutively, some days you get snagged up, and that's just one of these days.
Can you go into some specific issues you ran into and how you can not run into those issues next time?
Yeah, and so over at the Mtec we had some heat issues kind of at the beginning. Our material going into the hose was sitting around 82 degrees. As you go through the hose in the sun, the material obviously picks up the heat, which translates to hotter material at the end. To kind of combat that, you are able to pump slower and or add water to your mixture. When we added water to combat the heat at the end, we're getting a wet material, and so trying to find that balance between a loose material that will make it to the print head with a good temperature and a dry enough material to actively print thick layers is something we're still working on. We have a new system on our Mtec set. It's a different system than the Richmond house. Our base issue for the day, just maintaining that consistent material consistency. Kind of comes back to the water ratios, the pumping speeds you end up going at. When you have these issues and you have to pause, there's always a risk of material setting up inside your hose. When that happens, you have to flush the hose with water. We hit that once today in the middle of printing, so we cleaned our hose 3 times. That's not an uncommon number in the 3D construction world. Yeah, so start stopping, obviously every time you stop for X number of minutes, that 10-15 minute window, the best thing to do is to flush your hose so we don't risk the chance of clogging it and losing it. Quick cleans take around 20 minutes, 15 minutes. That's to flush water through, pressure wash into your components, and then you're able to go up and running. Doing that premature is for the better, rather than having to take down the hose and flush each hose individually, which can set you behind an hour, 2 hours, if not kill your day.
What kind of things will you implement tomorrow to ensure a successful print?
So tomorrow we're going to try getting off to printing a little earlier. Today we started around 8:30 due to material testing. Tomorrow we're trying to shoot for 7. And we're going to use the data we have from today with our water ratios, our pump speeds, our printing speeds, all to direct as the best path for tomorrow. A lot of it is conditional. You know, today's weather's going to be different, tomorrow's and the next day and the next day. And so you just have to be adaptive in this industry and roll your punches and keep your head and make wise choices. We're working with Habitat. This is the first time doing ladder. Everyone's been super helpful. Everyone's been really eager to work, eager to lend a helping hand if they're not actively doing something. This work is, you're not always consistently doing something. But you need to be able to turn it on 100% when you do. And a lot of people were able to really flip that switch today, and that was huge. So with this house, once it's complete, one of the things that we're going to be implementing is the homeowner will be gifted an Ender 3 V2, which is a standard FDM printer that can print around a 1 cubic foot. They'll also receive a series of STLs or 3D printed files that they'll be able to print in their house. After this project, we're going to stop printing houses in the field until next February. In that time, we'll be requiring a warehouse. We'll be doing material testing, machine testing, setting testing, kind of just honing in our practice. A lot of that stems from, there's a learning curve that comes with any of these machines, and being able to sit in a controlled environment and tackle those issues, being able to have a consistent system is huge, and we're hoping that this winter off will pay dividends when we come out next spring. In the warehouse, we're bringing on 20 different interns in different ranges. The printer operator, the mix master, if you will, and several other CAD systems and replacements, so we're able to run multiple things. Just visit us on our website, www.alquist3d.com, or reach out directly to us via one of the multiple social media platforms, and we'll get you into the process.
Big question everybody always asks is how much does it cost? I don't know if you can address any of that.
Yeah, so I do the printing, the cost analysis. We're getting close to where our numbers are projected to be. A lot of that comes with how many times you have to stop, how many times you have to empty the hose of material, how long you have to be printing, how many days you have to have a crew. And so all those factor in, so it's all about getting an efficient crew. The more efficient your crew, the better your cost-benefit analysis. I couldn't get a quote or give a quote for any number in my role.
That's fine.